Hello Year 11 and welcome to our third video here for probability. We have been looking at some language around probability, and we looked at sample space graphs, tables really, and tree diagrams, which are quite helpful in our last exercise. Today we want to look at sets and Venn diagrams. Okay, so again there's a little bit of language here. A set is a collection of elements, sometimes called members. I've never really used that phrase members before as parts of a set, but it pops up a bit in our textbook, and who knows, maybe it will in the exam. They both, as far as I can tell, mean the same thing. So a collection of elements or members. Now these might be numbers, these are our outcomes when we're talking about probability mostly, certainly in the context we've been working lately. Two sets are said to be equal if they have exactly the same elements. Now, repeating elements doesn't make a difference, as a matter of fact. I don't care if it's repeated or not. And the order that they are written doesn't make a difference either. Just a few people wandering around in the background. A set that has no elements in it is called the empty set. Okay, it's still a set, but it's just an empty set. It's a bit like the number 0, and it sort of looks like a 0 with a line through it there. It's called the empty set, and sometimes it's sort of important to refer to that. Intersection and union, these are quite important, and yeah, it's important we don't confuse them, though it's sometimes hard. The intersection of A and B is written like this, with this little cap here, sort of like an N. The intersection of A and B, right, is the set of every element that belongs to A and B, that's in both of those. Okay, so if something belongs to both of those groups, both of those sets, then that belongs also to the intersection of them. Not one or the other, has to be both, has to satisfy both criteria. The union of A and B, this little cup-shaped thing here, and I try to remember that looks like a U for union. So the union of A and B is the set of every element that belongs to either A or B. So it could be A, could be B, could be both. Okay, so the union is, as often as not, greater than the intersection. It's not impossible, they're the same, but it's a very special case. So intersection and union. Okay, intersection is both and union is either. Now, if A and B have no common elements, then they're called disjoint sets. They don't overlap at all, particularly if we think of that as a Venn diagram. They are disjoint sets if they don't share any common elements. So the intersection of A and B, if A and B are disjoint, their intersection is the empty set, okay, because there is nothing that they both share. Now, subsets of a set, right? A subset means that every element belongs to if everything in A, if every element in A can also be found in B, then we say A is a subset of B. Okay, so if I talked about, for example, if I was talking about even numbers and multiples of 4, then my multiples of 4 are a subset of my even numbers, because all of the multiples of 4 are even numbers. Not all even numbers are multiples of 4, but multiples of 4 is a subset of the even numbers. So, if A is a subset of B, then the intersection of A and B, the things where they overlap, is all of A. Right? The intersection of A and B equals A if A is a subset of B. And the union of A and B will be B, because we can think of B as being sort of larger and A is entirely contained within it. Rightio. There's this term here, the universal subset. And, we use a capital E here. It's going to be italicized to hopefully distinguish it from the capital E we've used for events not very long ago. The universal subset is more than just the sample space. It's everything that the outcomes could be, I suppose. It fits in neatly when we deal with complementary events. It is a little related to the sample space. Now, this counting rule for finite sets, finite meaning there's a limited number. So when I was talking about those sets like the even numbers, well, that's an infinite set. But as long as we have finite sets, the union of A and B, the size, or cardinality, the size of the union of A and B is the size of A plus the size of B minus their intersection, because that intersection is counted twice. It's counted in A and then it's counted in B, and we should only count it once. So it's A plus B minus their intersection. So let's have a look at this example, and perhaps you've seen questions like this in a maths test somewhere along the lines before. So much fun. Let's say we've got 100 people that are surveyed, and we ask them, have you been to Melbourne and have you been to Brisbane? 31 people say, oh, I've been to Melbourne. 26 people say they've been to Brisbane. And 12 people say they've done both. Now those 12, right, all of those 12 people said they've been to Melbourne. All of those 12 people said they've been to Brisbane. Okay, so this is not Melbourne only and Brisbane only. No, if you've been to Melbourne, you're one of that 31. If you've been to Brisbane, you're one of that 26. These 12 people belong to both of those groups. This 12 is the intersection of Melbourne and Brisbane. So we're asked how many people had visited Melbourne or Brisbane. Remember, or is keyword for union, okay, because it's going to be at the larger sort of figure. Now, to answer these questions, a Venn diagram can be really helpful. So here we go. I have my rectangle here, and that's going to represent, right, everything within my rectangle there is going to represent my universal subset, right, that capital E. Now, Melbourne and Brisbane, I've overlapped them because we are told some people have visited both. So, blue here for Melbourne, yellow here for Brisbane, and when they cross over, and it should appear green, no it doesn't, that's both. Now, we're going to look at a graphical solution to this first. We're going to use our Venn diagram and a certain amount of common sense, I suppose. The first thing I think that we can list on our diagram here is there's 12 both. So this area here, where the two ovals overlap, that's a 12. Now, if that's a 12 and all of Melbourne is 31, then the rest of Melbourne must be 31 minus 12 is 19. And if 12 plus something makes 26 people who've been to Brisbane, then that something will be 26 minus 12, or 14. So 19 people have been to Melbourne only, 14 to Brisbane only, 12 have been to both, and we can see there's my 31 together, there's my 26 together. That matches the information in the question. So, how many people have been to Melbourne or Brisbane? This is the union of Melbourne and Brisbane, and remember we've just developed the formula there. The size of the union is the size of A plus the size of B minus their intersection. The size of A is 31, the size of B is 26, the size of the intersection is 12, gives us 45. Alternatively, now that we've got this Venn diagram, I can just add those three figures together, and again I get 45. Brisbane, but not Melbourne. So I don't want to include that 12 there. These 12 people have been to Melbourne. I just want these ones here, so that's 14. Only one of the two cities. That means Brisbane only or Melbourne only, but not both. So that's my 19 plus the 14. It's 33. And neither city. So that is going to be the complement of the first one here. So it's 100 minus 45. 55 people have been to neither. So there we go. We've used a Venn diagram as well as this counting rule to solve a problem there. Brings us to the end and a recap. This is the intersection of A and B, and that means both A and B. And this here represents the union of A and B, and that means A or B or both. This symbol here represents the subset. It tells us that A is a subset of B, and that means that every element of A is also an element of B. And the size of the set A or B, the union of A and B, right? The size of that is the size of A plus the size of B minus their overlap. Rightio, that's the end of our third video there. Our next one will be on Venn diagrams and the addition theorem. There are some challenging ideas as we go through these, and certainly ponder over them and try to solve them yourself. That's great. But if you need some help, if you want some more clarification, please let me know. Thanks, guys.